Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux and running robot operating system. Last time I managed to get some testing done on this photo-transistor, which I provided with a black cap with a hole in it, and it turns out that it actually does work. But the big question is, considering the voltage, etc., is my GPIO still correct? I am about to test that, and in order to do that correctly, I have to take off this band cable from the GPIO. So I have done that, and now I can run the pin test and see whatever happens. This test can only test the input side of things. Well, that is exactly what I want. So what does it say? Pin 16 failure. Now the question is, pin 16 is where exactly? I think here somewhere. Then again, physical pins are here again, yeah. And that is wiring PI 4 BCM3 23. Am I using it? That is a very big question. And considering everything that I'm using, I am not using it. It says only pin 16 is failure. And I think that right now I am quite okay. So on with this. Then I still have to find a solution for this to measure or to be used with ROS. So for now let me quit this tab. I still have to start ROS core, which is done now. Ah, wait, I can't use that yet because I still have to reconnect the band cable to the GPIO again. So I will do that right now. Alright. And let's see what happens now. Disk usage in log directory is over 1 GB. Ah, that I have, yes, I have experienced that before. So where is this log? In slash dot, no. So that would be here and here. How long is it? How big is it? ROS clean command. Well, then it's pretty simple. Going back and then ROS clean. Well, what do they say then? I haven't done it in quite a while, by the way. Do I have the ROS core running? I don't think so. Yes, I actually do. So this is the ROS core running. 9605 is the process. Kill. So now it is done. Then I say ROS clean. Too few arguments. Alright. I have to check on this. Alright. With the command ROS clean purge, I did purge the log file. And I am getting back to what I did just a bit ago. In the now closed tab I did a pin test, and that said that pin 16 was faulty. Now looking back here, and yes, you have to read on the side. This is physical pin 16 and this is GPIO 16. Now GPIO 16 is pin 36 and I am not using that. However, physical pin 16 is being used because going here I say alright, it's an in. And that is a bit confusing because it did say it is an in, but on the same time I did use 15 before, and 15 is physical pin 15 is not faulty. So what should I do? Go to pin 15, which is GPIO 22, and I think I should do that. Although I don't want to run the risk that things are going to get ruined, but I'm not taking any chances, and I will put this one here, or try to anyway. Anyway, counting 4, 6, 8, 10, 4, 6, 8, 10, 12, 14, and this is 15. And with that change, I have to change this as well to 15, just to be sure. And with that I am going to start ROS core again. There you go. Now I should not get the message that the log file is too large. Alright. Apart from that, start the publisher. I said start the publisher. And start the subscriber. what's going on here? Ah, yeah, right. I have to change that because I still use 16 in here. So, yeah, little mistake, of course. This is better. There you go. And it says pass. Pass means there's no light, which is correct. There is no light. Is the switch still working? Yes, it is still working. And with a very little delay, of course. But that's about it. And now the big question is, if I shine a light, will that mean that it is seen? However, I am worried about the voltage. Truly worried. Because the maximum voltage on the mains, for example from here and the, or simply put, the red lines, is 5 volts. And the common output and probably also the input is 3.3 volts. So, is it wise to use something that has been measured to be 4.5 volts to let it over the GPIO? That's a very big question, and I'd better find it out. Information tells me that I actually will damage the GPIO when I put a voltage higher than 4.5 volts on it. So how do I bring the 4.5 volts from here back to down to 3.3 volts? Actually, in comes some electronics. So back to Scilab simulation. This is a constant voltage and I have set it to 4.5 volts. These are the common resistors that I've been using, 188 ohms. And by this circuit, which actually says, alright, this output voltage is being derived by multiplying this voltage with this resistance divided by the sum of these resistors. And this will of course not give my desired 3.3 volts, but who knows? Really? Because I need round here. This will work better. Yes. So this should give me some nice voltage. However, I see none. Alright. Do I miss something? Not really. No block parameters here. Nothing here either. And this is just a metric. So why don't I get some nice thing here? It says implicit blocks. Too bad. So I'm not seeing anything. I could actually say, alright, and by hand calculating something, but a simulation showing it is always nicer. And I have to deal with the 188 resistors anyway. I do have others, but those are, I think, even smaller. Let me see if I can grab those quickly. Those are some difference. And then quickly measuring. And what is this one? Yeah, even lower. So there's no use in using those resistors, unfortunately. So what to do? This one still gives nothing, but I'm saving it anyway. Save as. And no, not in here. Because I want, alright, voltage divider for the GPIO2 with ROS. And then in what format? Let me take XCOS. So, alright, that is saved. Now back to the to hopefully a solution with the formula. So let's get back to that. So back to Maxima. The formula is then that originally V out is V in voltage output, or the output voltage is actually the input voltage times resistor on the output divided by a resistor plus that same resistor. So when I take this and I say, alright, I want to have 3.3 volts. I do have 4.5. So this is what I have. Now what does this say? Yeah, right. But if I by rules of calculation say, alright, I can swap these two, then I say, alright, R plus 180 is 4.5 times 188 divided by 3.3, and then I get, and then minus the 188, and that's exactly what I have done here. So the resistance needed is 68 ohms. However, 3.3 volts is the maximum, and if I go back here to this one, it is actually maximum, because a high high input voltage would actually be over 2.3 volts, and I think that will be alright. So I need, going back here, I need to construct here a similar thing with a few resistors and a few wires, and then I should have the required voltage. So that is what I'm going to do now. I have the resistors, and yes, I only need 2. But I need to have some jump wires, so let's do just that. Well, now you can see that I have here the voltage divider. Here I set it up. It is quite well, small scale, but this wire is going is actually this wire, and since I have here the mass, I have here a very small tiny jump wire which is connected to this one. These two are connected here. So now the question is, does it actually work? So in comes the multimeter again. This is the wire, and this is again the flashlight. So let's measure it. It's 4.5 volts. Last time this actually proved to be working. The question is it working now? And I do have my doubts somehow. So I'm going to measure now. I hope not to block your view. Right here. It's 4.5 volts. So I shine straight into, this is better, I shine straight into the transistor, and it has actually totally no effect. And last time, which is 2 weeks ago or something, it absolutely did have effect. So the question is, what is the difference? Why doesn't it respond now? And without this, it is no use to expect a signal from ROS that it actually works. It says block now, and why does it say block? Because of the light sensor, and that, but it is not even connected because this is the wire. Does it say block then? Well, yes, it does say it, because there is no wire, so it is 0, so it says block. On the other hand, you see it say pass as well. Not this one, this one. So the question is, what is happening there? I'm not quite sure anymore. So taking this and you see the needle going back and forth. Now it's like low, then high, then low, high again. So if I shine now some light in it, so is this a measuring an error in measuring? I can't say. According to the calculation, it should be alright, but when measuring actually ruins the experience, I don't know. What does another meter say? That's another question. Well, another multimeter did not reveal any other outcome. So now the question is my real setup actually according to this? I think yes. This is mass, this is mass, and if I look here, it's just mass. Then one voltage source from the as an output from the phototransistor, providing the voltage which is here. This is wired to this resistor, and then this wire is just going from here. What else can I do? Not much, except maybe leaving the phototransistor as is. Other choice would be the LDR, but that requires digital to analog converter, or in this case an analog to digital converter, since the GPIO is digital and the output of an LDR is analog, and I still haven't found a nice LDR. So what does that leave me? Apart from having a broken port, I am not quite sure now. I want to go on with ROS, but I need to have something done. I will find something, hopefully before next time, and that yeah, I can do it with some other hardware, of course, but sensor readings are always nice. Thing that I have to keep in mind is that GPIO, in other words the Raspberry Pi, is digital. What I read is that I can use SPI, serial peripheral interface, but then again, I have to use it with another board. Do I have that? No, not yet. Can I use? Can I buy an appliance so that I get analog? Oh, no doubt. Will I use that? Maybe yes, perhaps no. And with that, I conclude this video. Where did it leave me? Well, last time good readings from the phototransistor. Now no good readings. I did build a voltage divider to to get 3.3 volts or something like that with this schematics. This works, well, not really, because there's no output. I may be doing something wrong, but I have yet to find out what and why. Not quite sure. And well, this experiment will be continued. So thank you for watching. If you like this video, please subscribe to my channel. You can also follow me on Twitter and Instagram. Also, please donate to keep my website and blog going. More information on my website, and also other projects are on my website. And this will be continued. Bye bye.